Namaskar. Today we discuss a new topic, that is acid, bases and salts. We are using so many things in our everyday life which contain acids, bases and salt. For example, we are using tomato, lemon, oranges, grapes and so many citrus fruit, as well as we are using vinegar also in our food. They all have acids. They have a similar properties that they are sour in taste. We are also using so many bases in our day-to-day life. For example, soap, detergent and toothpaste. They all have bases in them. They are bitter in taste, but we can't taste them. But if by chance we taste them, they are bitter in taste. We are also using so many salts in our day-to-day life. For example, common salt, rock salt, baking powder, ENO. These all things are salty in taste and they all have salt. So today we learn that we are using acids, base and salts in our everyday life. We are using so many other acids, base and salt in our day-to-day life. So your today's task: search 2 acids, 2 bases and 2 salts other than the given examples. Acids are those which release H plus ions or protons in the aqueous medium. We know that H plus ion is known as protons. Aqueous medium means water. Means acid release H plus ion or protons in the water, or when they dissolve into the water they release H plus ion. Bases release OH negative ion. OH negative ion is known as hydroxyl ion. Bases release OH negative ion in aqueous medium or water. Now come to the types of acid on the basis of ionization. We know what do you mean by ionization. Ionization is when any compound break down into its ion. So the acids are classified into 2 categories on the basis of ionization: strong acids and weak acids. Strong acids ionize completely and release all the H plus ion in water. For example, HCl. HCl is hydrochloric acid. H2SO4. H2SO4 is sulfuric acid. HNO3. HNO3 is nitric acid. Inorganic acids are strong acids mostly. They are also known as mineral acid. And one specific characteristic is they don't have carbon in the composition. Means in the formula they don't have carbon. Weak acids. Weak acid ionize incompletely in water. It means they release less amount of H plus in water. Generally, organic acids are weak acids. For example, acetic acid and formic acid. We have heard about vinegar. Vinegar contains acetic acid. And we have heard about the formalin. Formalin contains formic acid. Organic acids generally are weak acids H2CO3 is an inorganic acid, but it is a weak acid. Now come to the types of bases on the basis of ionization. Strong bases are those which release OH negative ion completely in water or ionize completely in water. For example, NaOH, sodium hydroxide. Sodium hydroxide is also known as caustic soda. KOH, potassium hydroxide. Potassium hydroxide is known as caustic potash. On the basis of ionization, bases again classified into weak bases. Now, what is weak bases? Weak bases are those which release less OH negative ion in water. Means incomplete ionization in water or in aqueous medium. For example, NH4OH. NH4OH is known as ammonium hydroxide. We have learned this formula in the previous chapter. Zinc hydroxide, ZnOH whole twice. Zinc hydroxide also is a weak base. Now come to the third category that we'll discuss today is salt. Salts are ionic compound that is produced when acids and bases are combining together in equal proportion. Means when an acid and a base react in an equal proportion, they form salts and the byproduct water also. The reaction is known as neutralization reaction. We can define the neutralization reaction when an acid and bases react in an equal proportion to form salt and water is known as neutralization reaction. For example, NaOH react with HCl, it forms NaCl and water. Sodium hydroxide when reacts with hydrochloric acid, it forms sodium chloride common salt and water. We are using the solution of sodium hydroxide and hydrochloric acid. Solid can't react. Liquid react with the solid or liquid react with the liquid or liquid react with the gas or gas can react. But solid cannot react. The second example, when KOH known as potassium hydroxide react with H2SO4. What is the H2SO4? H2SO4 is sulfuric acid. When potassium hydroxide react with the sulfuric acid, it forms sodium sulfate and water. So, we take a quick recap. Acid, base and salt. So, we learn that acid, bases and salt we are using in our daily life. We have learned the examples of acid: tomato, vinegar, citrus fruit, oranges, lemon, grapes, etc. Acid are sour in taste. Bases we are using soap, toothpaste, detergent, bitter gourd. Bases are bitter in taste, and we are using salts: common salt, rock salt, baking powder, Eno, etc. Salt are salty in taste. We learn that acid release H plus ion in aqueous medium, bases release OH minus ion in aqueous medium. We have learned the types of acid on the basis of ionization: strong acid which ionize completely in water. For example, hydrochloric acid, H2SO4, HNO3, etc. Weak acid we have learned. Weak acid, those ionize incompletely in water. For example, acetic acid, formic acid. We also learn the types of bases on the basis of ionization. Strong base which release OH negative ion completely in water means ionized completely in water. For example, NaOH and KOH. We have learned weak bases. Weak bases which ionize incompletely means release less OH negative ion in water. For example, ammonium hydroxide and zinc hydroxide. We learn about the salts. Salts are ionic compound. Salts are made up by the reaction of acid and base through the neutralization reaction. What is the neutralization reaction? Neutralization reaction in which acid react with the base in equal proportion to form salt and water. We have learned the example when NaOH react with the HCl, it form NaCl and H2O. When KOH react with the H2SO4, it will form Na2SO4 plus H2O. Now come to the next, concentrated acid and dilute acid. On the basis of water present in the acid, we have classified acid into two categories, concentrated acid and dilute acid. Concentrated acid in which the amount of water is very low, means the percentage of acid is very high. The concentration of water mixed in acid is lower than the concentration of acid itself. The second category, dilute acid, in which the concentration of water is high. The dilute acid, the concentration of water mixed in the acid is higher than the concentration of acid itself. How will you identify that the solution is given to you is an acid or a base? So, we have few tests. Indicator test, we have litmus test and pH test. We have two type of litmus test, blue litmus test and red litmus test. We have litmus solution as well as we have litmus paper. There are two type of litmus solution or litmus paper, blue litmus paper or blue litmus solution, red litmus paper or red litmus solution. When we mixed acid into blue litmus solution, the blue litmus turns to red, and when blue litmus solution mixed with the base, there is no change in the blue color. We can learn acid, the D, and acid and with the D, acid turns blue litmus to red, D. Now come to the red litmus solution. When base mixed with the red litmus solution, the red litmus turns to blue, and when an acid mixed with the red litmus solution, there is no change in the red litmus solution. So we have learned that acid turns blue litmus to red and base turns red litmus to blue. Base turns red litmus to blue. Acid turns blue litmus to red. The second test, we have pH test. We can take pH indicator also to identify acid and base. pH scale has a range 1 to 14. The pH range 1 to below 7 shows that the solution is acidic. The pH range 7 indicates that the solution is neutral. The pH range above 7 to 14 indicate that the solution is basic. 0 to 7 indicate the acidic nature, 7 indicate the neutral, 8 to 14 indicate the basic nature. If the value of pH decreases, then the acidic nature, acidic strength increases. Means if a solution has pH 3 and the another solution has pH 6, then the solution 1 which has pH 3 is more acidic than the second solution which has pH 6. Same as if the solution has pH more than 7, then solution is basic. We can take two solutions. The first solution has pH 9 and the second solution has pH 13. Then the second solution which has pH 13 is more basic than the solution 1 which has pH 9. We can also check the concentration of a solution on the basis of pH.